extension to section 4.4. Well, today we're going to look at trig things a little bit different and solving some equations over the entire circle. Maybe kind of like the bonus that was on the no calculated part of the test. Remember that bonus? It asked you to give 2 answers. Oh, not that part. The first part of the test. Yeah, we did that perimeter problem before, but most people didn't remember how to do it. Well, I'm not telling you because Katie hasn't taken the test yet. Because she's going to come in the morning because she doesn't want to miss notes. She took the first part this morning. She came in. Chapter 5 is all about trig identities and trig proofs, and today is just kind of a little bit of something because I feel like it helps us in the rest of chapter 4. After today, we're going to start graphing sine and cosine and all of those lovely functions instead of just solving equations. We're going to graph them, so that's exciting. But we're going to write these in terms of the reciprocal function. So we know that sine, we can write sine as opposite over hypotenuse. We can write sine as y over r. If it's a unit circle, we can write it as just y. We can write it lots of ways. But I could also write it in terms of cosecant. If sine and cosecant are reciprocals of each other, do you agree that I could also say sine of theta is the same as 1 over cosecant of theta? Do you agree with that statement? We call these the fundamental identities because they are ones that probably we use the most, ones that you probably could come up with on your own even without me giving them to you. And based on that, you probably could go through all of these. Yes, sir. I don't know. I don't think so. Pretty sure.
Yeah, there was. I left it blank.
Cotangent. Cosecant's really tough. Really tough. No, like cosecant. Those flaps. You hear me? Just like, I don't want to say, ship different tests.
Well, there's 2 different tests, but
Cotangent 3.6.
oh, well, we did that. Like, that's nothing. Like, you should know how to do that already.
I think I did. I don't know.
Shows out.
No, because Katie hasn't done it yet.
Leave the problem.
Friday, you're gonna get your test back. The problem that I saw is lots of people I don't think were in radian mode on that problem. Yeah, so like I think like a lot of people set it up right. Like, they showed their work, what they typed in their calculator. They were all the exact same except for a change of numbers. Like, it's really easy to make different versions of tests because you just change angles and change the numbers. And so it was super easy to make 2 tests that I felt were equally difficult or easy. So that no one can say one was easier than the other because I just went through and changed all the numbers. So there were 2 different tests on each one. Oh no, but I made sure that all of them either worked out nice or didn't work out nice. Like, so on test A, if it was a nice one, then on test B, it was a different nice one. I promise. You can check it out. Good luck. 1 over cotangent. And this is, we actually did this. You're right on that question on the test. Like, that's exactly how I showed you in the last chapter. Yeah. Normally, you don't do this because we have sine, cosine, and tangent on our calculator, so we don't need to flip it. But on cosecant, right, there is no cosecant button on my calculator, so we had talked about that you do 1 over sine of that angle. And for secant, you do 1 over cosine. And for cotangent, you do 1 over tangent. We can also write tangent and cotangent another way, and I kind of hinted to this on that last worksheet that we did before the test. That tangent, we could write it as 1 over cotangent. We could write it as opposite over adjacent. We can write it as y over x. But we can also write it in terms of sine and cosine. So when you see tangent, if you know sine and cosine, tangent of theta is the same as the sine of theta over the cosine of theta. And remember that comes from tangent is y over x. So y sine and cosine is x. Which means if tangent is sine over cosine, what is cotangent going to be? Yeah. Which means today I'm going to give you a couple problems that you could just draw a picture and you could do the same way we've always done, but you could also just use these identities and you don't ever have to draw a picture because you could just write them in terms of the others. We also have some lovely identities called the Pythagorean identities. And again, we'll use these a lot more as we progress on, but I feel like they're kind of helpful, so I want to give them to you now. And there's 3 of them. One of them is one that usually people remember, and then the other 2 people forget a lot. One of them is in terms of sine and cosine. So here you go. If you have the sine squared of any angle, so sine squared theta plus cosine squared theta, again, you just square it. It will always equal 1. So you take any angle you know. If you take the sine of it and you square that value, or you take the cosine of it and you square that value, when you add them together, you'll always get 1. Where does that come from? The Pythagorean theorem. Isn't sine normally the y value? So isn't this like saying y squared plus x squared? And in the unit circle, what's the radius? 1. Right? So that's where that comes from. It's not some magic thing that they made up. It's just using the fact of our x, y, and r values. There's 2 other ones, and we'll use these a lot more in chapter 5. Let's see if I remember these. 1 plus cotangent squared of an angle equals cosecant squared. We're going to finish chapter 4, and then we're going to do chapter 5, and we're going to do chapter 6, and we're going to do chapter 8, and then maybe come back to chapter 7 and 6. Chapter 7 is only 2 sections. We only do 2 sections of chapter 7, so it's not even really a chapter. I call it a quiz for the course chapter. Like record every day when I'm gone for 8 weeks. No, you're gonna have Mr. Pruitt, and I have this lovely binder that I've been making. This lovely binder with full of notes and my homework and filled out notes, and I have all the notes saved, and I have saved all the notes that I recorded last year. I've put in a file that if he wants to use my notes from last year, but I really just don't have enough time. I can show him how to put them on Harmony. So. My Big Campus. I put them on YouTube. I feel like it works much better through My Big Campus. 2010. All lowercase, all one word. Miss Dixon 2010. That's just when Mrs. Dixon. One plus tangent squared theta equals secant squared theta. That's the other one. I don't know. I don't care. I'm not trying to get views. I just put them there for absent children. We're going to use this in a minute, and I'll show you how we can use this to help us solve a problem. Is it required that you have to use this right now? No. But these are going to come up. Chapter 5. Probably I'm going to be on maternity leave sometime during chapter 5. Like I'm going to be here for part of chapter 5, and then I'm going to be gone after that. So that's kind of what happens. I don't really know when the baby's coming. So, you know, that's my plan. March 18th is my due date. If I haven't had the baby by March 18th, I'm not coming back. So the week before spring break, whether I've had the baby or not, I'm done. Like I'm not coming to school when I pass my due date. I refuse.
What if you're here, the baby
No, I'm not. I'm not gonna be here. I'm day of my due date. March 18th is a Monday. That's my due date.
Babies come
That's
early.
when Mr. Pruitt will be here.
Babies come early.
They do. I had Parker a week early. But you know what?
So what if you're here?
That's okay.
I can't deliver, baby.
It's okay. Here's a little thing of advice for you. Labor doesn't happen like on TV. Only 1 out of 10 women does their water break before they go into labor. So like there's probably a good chance I would have labor pains, way before my water would break, and I would be like, I think I'm gonna go home early. And then I would go home. I wouldn't just stay here.
That's a 1/10 chance.
It is. It's true. Could it happen? It could. It's okay. Look at all this space. It's not gonna bother you. It's not gonna touch you. It would just be okay. It would be so exciting.
It would not be exciting. I would be scary, and I would.
It wouldn't. And just because, and here's another thing, even if my water broke in class, the baby doesn't come right then. Like, if my water broke, I would be like, oh crap. And then my pants would be wet. And then I'd call the office and be like, my water broke, you better send a custodian and someone to cover my class. And then I'd wait for someone to come cover my class, and then I'd drive to the hospital. It's okay. You guys think that I'm just gonna be like, oh, my water breaks. Oh, I have to push a baby out 2 seconds later. Like, that's not how it works. I promise.
Sometimes it does happen.
No, not that quickly. It's not that quickly.
No, they said that sometimes that can happen. Like, it's just boom. Wham, bam, bam.
Okay, I was in labor for, I don't know, like 30 hours with Parker. So even if we say second baby, it should go at least half as fast. I got 15 hours. I'm good.
Yeah, but what if the sub could go here?
Well, I don't think they'd send a sub. They probably would send Mrs. Boyce or someone in a hurry, and Mr. Puckett would have a cow. Like, you don't even understand how stressed Mr. Puckett would be if that happened. Probably they would want me in a wheelchair, and I would refuse. And they probably would tell me I couldn't drive, and I probably would just drive myself.
Call the lifeline.
Because he stresses out way too much about pregnant people.
It's really
Not around here. He didn't even have a baby around here anymore. Okay, let's. It's okay. It'll be alright. I promise.
Don't worry.
You guys are ridiculous.
I think I just saw it too.
He kicks all the time. I promise. Let's focus, okay? You would actually have time to do your homework today if we could just get through this. I am. All this baby talk. I feel bad for poor Blake Doolin, who just had to leave and asked me if I'm recording the notes. I'm sorry, Blake. It's all Logan's fault. Here's some other things that are true. Co-functions of complementary angles are equal. That's a whole lot of math words here. This was a question that was on our quiz that still lots of us missed on the test. What are complementary angles? I don't remember. What does complementary mean?
90 degrees.
They equal 90 degrees. Hence my 90 there. Or pi halves if you're in terms of radians. Co-functions are angles that go together, and so that's the new part here. So sine and cosine are co-functions. So if you have the sine of 90 degrees minus any angle, that will always equal the cosine of that angle. And I'll throw some real numbers in there in a minute. And cosine of 90 degrees minus any angle is always going to equal sine of that angle.
So it's just gonna memorize.
You don't have to memorize it. Like, you just know, you need to know which ones go together. And if you remember that complementary angles go together, so let's think of an angle, a really nice angle that we know, like 30 degrees. Or pi 6. So let's say we put, I'm going to go with 30 degrees since I'm in degrees here. If I put 30 degrees in here, do you agree that that would say sine of 90 minus 30 equals cosine of 30? If I just filled 30 in for theta? Yes? What is 90 minus 30? Does the sine of 60 degrees equal the cosine of 30 degrees? Well, we should know that because 30 degrees is pi sixths, and 60 degrees is pi thirds. Don't the sine and the cosine just switch places? The x and the y just switch places? It works for any angles. It doesn't have to be ones we know. We could say that the sine of 50 degrees is going to equal the cosine of what? 40, because I'm trying to get them to add up to 90. Complementary angles. And so we're going to look at one in a minute. Sometimes they just ask you a question, and you're like, how am I supposed to know this? Well, if they gave you the sine of 50 degrees, and they asked you to find the cosine of 40 degrees, they want you to realize, oh, they're complementary, so I can put them together. So here's the big thing you have to know. Sine and cosine go together. They're all paired up. Tangent and cotangent go together. They are cofunctions, which means if the two angles add up to 90, the tangent of the one angle will be equal to the cotangent of whatever its complement is. So write that tangent of 90 degrees minus theta is equal to cotangent of theta, and cotangent of 90 degrees minus theta is equal to tangent of theta. And I put 90 here in degrees, but it could also say pi halves, because pi halves is the same as 90. And what's left? What are our two trig functions we have left? Secant and cosecant, right? So secant of 90 degrees minus any angle is going to equal to cosecant of that angle, and cosecant of 90 degrees minus any angle is equal to secant of that angle.
Why would it be like that? Like, why would sine go to cosine?
Because
Or
it
why
just,
would sine go to cosine?
because they're not, it's not true, right? Like if I took the sine of 60 degrees, that's not equal to the cosecant of 30 degrees. Like it's just not a true statement because you're flipping it over. Tan and cotangent go together, I know, because it's opposite over adjacent and little special ones. There's no radius going on in there. So I wrote this down here, but we already did this. I could say that the sine of 30 degrees is going to equal the cosine of 60 degrees, because 60 plus 30 adds up to 90, and they go together, so I know that. Okay, I think that's it for my little rules. Now let's look at what you're going to do on your homework today. We're going to do two different things on our homework today. One is we're going to use these to find some other missing trig values. And the other thing is we're going to solve some equations in a different way than we've done before. So let's see if we can do some of these. So this is two questions on your homework today. It says use the given information or the given function and trig identities to find all the indicated trig functions. Technically speaking, you could probably get around using the trig identities, but I want to show you how the trig identities can help us here. And so I think I have 4 problems here. Maybe I'll just show you all these, and then we'll see if we can compute them. And the idea here is I'm trying to see if I can figure this out without actually maybe drawing a triangle and drawing a picture. Not that you couldn't do it that way. And so they give us that the secant of theta equals 5, and the tangent of theta equals 2 squared root of 6, and they ask us to find 4 things. On your homework, these 4 things are labeled as A, B, C, or D, and every year I have people that just circle C and think it's a multiple choice question.
So this is there's no 4 parts to every problem.
No, 2 questions like this on your homework. It's really not that stressful because there's not that much work to show. If they give me secant, can I find cosine without doing much work? Because I know that cosine of theta is the same as 1 over secant of theta, right? That was the little identity that we just wrote out. Isn't that true on the first page? Or maybe just remember that cosine and secant are reciprocals. If secant is 5, what does cosine have to be? 1 over 5, right? Could you have got that without that identity? Yes, because we've already talked about them being reciprocals. But that's the idea, using the identities. really not a lot of work there. I can do the same thing with cotangent, right? If I know tangent of theta, can I find cotangent of theta without so much work? Because cotangent is 1 over tangent, or 1 over 2 square root of 6. Do we leave our answers like that? No, I still had issues of people on the test leaving square roots in the bottom, not simplifying square roots. But I would multiply the top and the bottom by the square root of 6, and I would get square root of 6 over what? 2 times 6 is 12. We don't cancel something out inside a square root with something outside of a square root, although you really want to because it's a 6 and a 12. That would be your answer. Number 3, when you see something like number 3, it should remind you of what we just wrote out. Co-functions of complementary angles are equal. So if I see something with 90 degrees minus theta, that probably means I want to use one of those things that we just wrote out. What did we say this equals? The cotangent of 90 degrees minus theta is always going to equal what? Just tangent of that angle. So that's one that it really is nice to use that value. I don't know what theta is, but I know if they ask me to find the cotangent of 90 degrees minus that angle, it's going to be equal to tangent of theta, which means it's just the same thing as tangent, 2 square root of 6. So although there's 4 parts to this problem, notice there's not really a whole lot of work I'm having to do. It's just kind of using those formulas. What about sine? There's lots of ways you could do this one. I'm trying to keep from using, I'm trying to keep from drawing a picture is what I'm trying to do. I'm trying to use an identity that I have that I could work out here. We have a couple. Could I use maybe this one? Sine squared plus cosine squared of theta equals 1. Remember that lovely one I gave you? Do I know what cosine is? We did it already. It was number 1, right? I could solve that. I think I could also use the tangent one that has sine in it. Think about that one. Tangent of theta, we said equals sine of theta over cosine of theta. Do I know what tangent of theta is? And cosine of theta, and I could solve that for sine of theta. So the idea is maybe try to pick one that you know what's there and you can plug in and solve for it. As long as you get the right answer, I don't care. If you draw a triangle and you get the right answer, I don't care either. I'm just trying to get you thinking about these identities. Which one of these looks better for you? The first one? Just like we did on the test, hopefully, right? If you know the secant is 5, don't you know 2 sides of that triangle? Or, maybe? Possibly? Could be simplified though, so that's kind of the weird part about it, because the tangent, yeah, it just depends on the problem. I think this is a better choice. Tangent, so I heard someone say that. You want to do that one? FYI, if you do this one, when you plug in the number, like when you plug in 1/5, you're really plugging in 1/5 and then you're squaring it. That's what cosine squared means, so just throwing that out there if you want to do that one. How would you square 1/5? Oh, well, I plugged 1/5 in. Alright, let's just do both. I'm trying to solve for sine, right? So what is 1/5 squared? And then what would I do? Because I plugged in what cosine of theta was. Does that make sense? Because I knew cosine of theta was 1/5, so I plugged that in, and then that little squared means I squared that value. So I would get that sine squared theta equals 24 over 25. I want sine, not sine squared, so how do you undo squaring something? You square root it. When you square root a fraction, you square root the top and you square root the bottom. So I would get the square root of 24 over 5. And I shouldn't leave that as a square root of 24 because I could simplify that. That would be 4 times 6. So that would be 2 square root of 6 over 5. Right? You should get the same answer over here, but I wanted to answer his question there. The tangent was 2 square root of 6. Right? No. Is that right? No, I feel like we don't get the same answer. We do? Oh yeah, sorry. So I was multiplying by 5, but that's not really what I would do. Cosine of theta is 1/5. So I was trying to do this math in my head, and I was doing it incorrectly. Dividing by 1/5 is the same as multiplying by 5 over 1. So that's really 5 sine of theta. If you bring that 1/5 up, flip it over. So then you divide by 5. And you do get that sine of theta equals 2 square root of 6 over 5. Which is probably less work than the Pythagorean one. But both of them give you the right answer. So 1 out of the 4 maybe has a little bit of work to do. But most of them are just going to be straightforward. What else can we do now? Well, because we know our unit circle, and because hopefully we feel comfortable with some of these, we can solve some equations now over the entire circle instead of just one quadrant. So that's the last thing that we're doing today. This maybe looks familiar to you from the no calculator part of the test. It was the bonus question. Only on the bonus question it was cosecant. Well, you know, people got it right. But a lot of people got at least, I made it worth 2 points. There were 2 answers. I made it worth 2 points if you got at least one of them, which you should have been able to tell me where does secant equal 2, or on the test it was cosecant equals 2. But the part that made it bonus is we haven't talked about this. It says find the values in both degrees and radians, which means you have to give me the answer that you get in both degrees and radians over the entire circle. So going all the way around one time, from 0 to 360 and from 0 to 2 pi. So we did lots of questions like this. There were questions on the test that weren't bonus that said find secant of theta equals 2, and then it would say like cosine is positive, so it would tell you what quadrant you're in. This one they don't tell you what quadrant you're in. They say in the entire circle, tell me every theta value that has a secant of 2, which means first of all we have to figure out what we're doing. I'm not a big fan of secant. I like to change it. If secant of theta equals 2, what do I know that cosine of theta equals? 1/2. And so this is asking me where on my circle, or what angle all the way around has a cosine, or unit circle, an x value of 1/2. Somewhere up here in quadrant 1, there's an angle there, right? Yeah, I think it's up here. If you're a unit circle person, this would be the point 1/2 square root of 3 over 2. If you're a triangle person, you could draw that down, and this would be 1, 2 square root of 3, and you have a cosine of 1/2. So I could say, I know that theta equals, in degrees, that would be 60 degrees, or in radians, that would be 5/3. And if you got that, I think on the first part of the test, it was cosecant. If you gave me that one angle, I gave you 1 bonus point. But here's why I made it bonus. That's not the only answer. Is there another quadrant where cosine is positive? Over here is cosine positive? No, it can't be 1/2 there. What about down here? What about over here? Is there another angle down here that's going to give me an x-coordinate of 1/2, or a cosine of 1/2? Yeah. Right down here at 5 pi-thirds, which means for every one of these problems, there's always going to be 2 answers, because if you remember, every trig function is positive twice and is negative twice. So you can always find that other quadrant and get that second answer. So it's the same, the third down here, I think I heard Brinley say it was 5 pi-thirds. I do so much better in radians than I do in degrees, but that would be 60 degrees less than 360. So is that 300 degrees? And so the big thing is, it does not say, hey, there's 2 answers. You have to be aware, if you're going around the entire circle, and they don't give you restrictions about you're only in quadrant 1 or you're only in quadrant 3, then you're always going to get 2 answers. So let's do another one, like this one. You can leave it in cotangent. I'm just a big fan of sine, cosine, and tangent. So I'm always going to change it just like we did back in the first part, chapter 1, chapter 4, whatever, chapter 1. This one's not much different because of the cotangent one's the tangent's one, right? So what I'm asking myself first is, do I know an angle in my circle where the tangent is going to equal 1? Tangent is y over x, or opposite over adjacent. So unit circle people, you're thinking about what points are my ordered pairs the same, right? The force. The force. Right? At high force, isn't this square root of 2 over 2, comma square root of 2 over 2? So if my x and my y are the same value and I put them over each other, isn't that going to equal 1 every time? And in the triangle, 1 over 1, that's where you get that from. And so just like part of your test that you took, there's not really a lot of work to show except for maybe drawing a little picture. It's about knowing those values, which is why it's so important that you still know your unit circle or your triangles. And do you agree in quadrant 1, tangent would equal positive 1? Which would be pi force, or what is that in degrees? 45 degrees. Is there another quadrant where tangent is going to be positive, or where those ordered pairs are going to be the same? Yeah, quadrant 3, they're both negative, but when you put negative square root of 2 over negative square root of 2 over 2, you're still going to get that answer. So that's where the big thing today, you're going to get 2 answers, or 4 answers if you're writing them in both degrees and radians. What's the degrees or the radians down here? 5 pi force, 180 plus 45, 225, is that right? I'm telling you, I do so much better with my radians than my degrees. Does that kind of make sense what we're doing there? We can do this with angles that also we use our calculator with, but your calculator only gives you 1 answer, so I'm not sure whether this is my next one or not. Oh yeah, let's look at one of these. What if they give you a really ugly one that you're not using the circle with? You can still do the same directions. You can still find 2 answers where that's true. And again, this just says, they're telling us that the cotangent is this lovely number here, and they're saying, give me the angles between 0 and 360. If you're going around the entire circle, then you're going to give me 2 answers. This also tells me that my calculator should be in degree mode, because it says degrees. If it said 0 to 2 pi here, then you would make sure you're in radian mode. So this is different than what you had to do on your test yesterday, because on your test yesterday, I gave you the theta value, and I asked you to use your calculator. This one we're trying to solve for theta. So first of all, there's no cotangent button, right? So the first thing I'm going to do is I'm going to say if cotangent of theta equals this, then tangent of theta is going to equal 1 over this. Do you agree with that? What button do I hit on my calculator if I'm trying to solve for theta? Inverse tangent. Right? So step 1, you got to change it to tangent because there is no cotangent button. In order to solve for theta, you're going to hit inverse tangent of 1 divided by negative 4.3315. My calculators, you have to hit the division button, not the fraction button, because it won't let you put decimals in a fraction. It'll say error. You can just use the division sign. Some other calculators might let you do that. Make sure you're in degree mode, because if you're not, you're going to get the wrong answer. I don't know. Let's just go 2 decimal places. Negative 4. Did you get like negative 12.9999? So if we're rounding to 2 decimal places, we would just round that to negative 13 degrees. You with me on that? Your calculator is going to give you a certain answer every time. My question to you is, does this fit the restrictions that it gave me to give my answer in? My answer is supposed to be between 0 degrees and 360 degrees. Does that answer fit that? How can I make that answer into an answer that fits that? Add 360, because I don't want the negative angle, I want the positive angle, which means I want to go all the way around again. Your calculator gave you the negative one. So you need to add 360 to that to get your answer. And so you get 347 degrees. Everyone with me on that? That's only one, right? So you got to use your calculator. Sometimes your calculator is going to give you a negative answer, and the rules here say we have to give a positive answer, so we're just going to find the coterminal angle. What quadrant is that in? Quadrant 4. So somewhere down here, I'm just going to kind of draw a line. That has a tangent of whatever that ugly number is. What other quadrant does our answer have to be in? What other quadrant has a negative tangent or a negative cotangent? Quadrant 2, right? Because quadrant 3 is negative and negative, positive, positive. So it's going to be up here in quadrant 2. We got to figure out what angle that's going to be. Can we maybe use reference angles a little bit? This angle right here is going to be the same as this angle right here. Right? Those reference angles, think about all of our ones on our unit circle. Can I figure out what this little piece right here is? Yeah, it's whatever 360 minus 347 is, which is 13, is that right? Yeah. So that's 13 degrees, which means I know this is 13 degrees. And notice my picture's terrible. I'm just trying to get an idea here. If I know that reference angle is 13, can I figure out what the measure would be from here to here to get over in quadrant 2? Yeah, so those reference angles are coming back to us. So the other angle is going to be 180 minus 13. So what is that, 167? And if you take the tangent of 347 and the tangent of 167, they should be giving you the same value there, which is whatever this is when you divide it out. So you can use your calculator to do that also. A little bit more work, but it's the same idea. How do you feel about that? They could make you do that in radians. If this said from 0 to 2 pi, you do the exact same thing, except for your calculator would be in radian mode, and you would get a radian answer and not a degree answer. Okay? I'm going to stop for now because I want to give you some time to start your homework. Oh, look, I guess I don't even need to show you this. Your homework is a worksheet. But I want to kind of give you some tips on this.
You can turn this in tomorrow, or just like do our homework? Part of our homework.
This is your homework. You can have homework with you. So this counts as 4-4 day 1 homework. And tomorrow you'll get an assignment sheet that says 4-4 day 1 is worksheet. Look at 1 through 6. 1 through 6 says solve the equation in the specified interval. Give exact answers when possible, which means if it's from the unit circle, like look at number 3, look at number 4, look at number 5, all those seem like those are unit circle ones to me, which means you shouldn't need a calculator on those. But then the other ones, I think you have to use a calculator, because 2.5 is not from my unit circle, negative 1.7 is not from my unit circle, so you definitely need a scientific calculator to do these. And notice, if it says from 0 to 2 pi, you need to be in radian mode, or you need to give me radian answers. If it says from 0 to 360, you need to give me degree answers, or be in degree mode on your calculator. And then 7 and 8 at the bottom, that was like our first example. They give you some information, and they ask you to find those other things. Those are not multiple choice questions, which means don't just circle B, right, and move on, because that's what people do every time.
First thing, so I can ask you.
Yes. Right, and that's it. There's 8 questions.